while traveling through this world of war. Here there's no sickness, toil, or danger in that bright world to which I go. I'm going there to see my father. I'm going there, no more to roam. I'm only going over Jordan. I'm only going over home.
Welcome to Your Brain, a Personal Tour, Seminar 6. Today is our last seminar, and we'll talk about some difficult topics, but also about some amazing progress. The goal of the seminar will be to talk not only about some tragic events in the life of many brains, but also about awesome progress that's being made with new tools, new software, and new understanding. My personal goal is that each seminar participant gains a better understanding of these brain conditions and a better understanding of how each of you can take steps today to minimize and protect your brain. The subtitle deals with contributions to this area. They come from many sources. Some are quotidian, like dog walking. Some are sci-fi, like Jedi monkeys. I hope you'll be as fascinated as I was to understand how each contribute to the relief of suffering. Welcome to the seminar. I hope you enjoy it. Today we'll talk about three areas. First, Alzheimer's disease. Alzheimer's disease is a specific case of a more general disorder called senile dementia, and it's the number one fear of Americans in terms of growing older. These diseases place dramatic burdens on family, on friends, and on communities. But recent advances in brain science show hopeful potential. And there's something that each and every one of you can do today to help protect yourself. Next, we'll talk about new horizons, both in your brain as well as in your gut. The research here is as fascinating as it is practical. Finally, we'll talk about recovery from trauma. Injuries not only to your brain and how to repair them, but also on how your brain can help recover from a devastating trauma to your body. Spectacular progress is being made here, and that means life-changing events for the positive for many people. Now, this is not a downer seminar. Progress is being made in each of these areas. The following clip is from a well-respected neurologist on a topic that's near and dear to each of us, protecting our brain. There's a way we can do something today that will help us now and in the future. Let's take a look.
Back in the day when I was in medical school, we were told that each of us was given a certain number of brain cells, whether it was 100 billion or however many brain cells you were lucky enough to get, and that was pretty much it. That was what you were left with, and every time you drank a beer, you'd lose 30,000 brain cells or whatever the number was. For some reason, I don't remember. But that said, the idea that humans don't grow new brain cells is actually now fully demonstrated to be wrong. How exciting it is that we possess the ability to regrow brain cells, a process called neurogenesis, and that we retain this ability throughout our entire lifetimes. So the question you may be wondering is, well, what can I do to increase neurogenesis? I'd like to grow back new brain cells, and here's how to do it. Neurogenesis happens when your brain produces more BDNF. It stands for brain-derived neurotrophic factor. That's sort of the growth hormone for the brain, and we know that you can turn on the amount of BDNF in your brain with at least two things. Number one, physical exercise, specifically of the aerobic type, and number two, by taking into your body a specific omega-3 called DHA. Both of these things stimulate BDNF and therefore lead to increased amounts of BDNF. Let's take a look at how physical exercise makes that happen. Published in 2011 in the Proceedings of the National Academy of Science, a study called Exercise Training Increases the Size of the Hippocampus and Improves Memory. What the researchers looked at was the size of the brain's memory center called the hippocampus, which we know tends to shrink as we age in perfect correlation with our declining memory. And the study looked at 120 adults over a 1-year period. Half the group did some stretching exercise, the other half did some aerobic exercise. They measured the size of the hippocampus with MRI scans. They measured their blood levels of this brain-derived neurotrophic factor, or the brain's growth hormone, and even perhaps most importantly, they measured their memory function at the beginning, at 6 months, and in 1 year. And what they found was that those individuals who did the aerobic exercise in comparison to those who just did stretching had a marked increase in their BDNF levels, meaning more brain growth factor. And in addition, those individuals who did the aerobic part of the story had, quote, substantial improvement in memory function. These results clearly indicate that aerobic exercise is neuroprotective, and that starting an exercise regimen later in life is not futile for either enhancing cognition or augmenting brain volume. There is no other prescription. There is nothing that can be written on a prescription pad, although I tend to write that on a prescription pad, please exercise. There's nothing you can get at the pharmacy that will improve your memory and protect your brain. And now we know that the simple act of aerobic exercise will not only improve memory function, but actually allows you to regrow new cells in your brain's memory center. That's pretty powerful information. I'm Dr. David Perlmutter.
I want to show one slide from that video again. Please note that the neuroprotective effects of exercise can be enjoyed even, as they say, later in life, a stage that I, and perhaps many of you, are familiar with. So there's no excuse not to exercise. If you're not doing that, start today. But please talk to your doctor or healthcare professional first. What kind of exercise? I read the study and found some very interesting facts. First, the average age of a study participant was 65 years of age. Second, the aerobic exercise they used was brisk walking. This walking had to be aerobic, so that meant getting your heart rate up to 60, 70, 75% of your maximum heart rate calibrated by age. This is a heart rate chart with a red dot on the target range for the study participants. This level is the kind of exercise that has now been shown to be neuroprotective. It helps you grow new brain cells. It helps you improve your memory. So want to grow more brain cells? Want to increase your memory? Then exercise. No matter how late in life, most of us can do this today. However, for some people, vigorous walking can be a challenge. Well, I'm happy to say that there are many forms of exercise that can be positive for mental function. For example, Tai Chi. In a recent review of the literature, about a dozen randomly controlled trials of Tai Chi were found to be effective in enhancing cognitive function in older adults, especially in a group or social setting. So if you don't like to walk briskly, try Tai Chi with some friends. The DHA Dr. Perlmutter was talking about can be bought in a variety of forms in your local supermarket. You can go to a specialty vitamin store, but it's not necessary. It's typically found either in a pure form, labeled DHA on the bottle, or more commonly, fish oil. Fish oil will have both omega-3 EPA and DHA, but recall it's the DHA that has been found to be clinically impactful for your brain. There's nothing that I found in my readings that said any particular kind of fish oil is better than another. So it doesn't have to be wild-caught salmon. These can be factory farm fish. In most scientific studies, the DHA is obtained from algae, so you don't have to pay extremely high prices in order to obtain this chemical from happy fish to protect your brain. Walking is a great way to start exercising, especially with a dog. If mobility is an issue, then talk with your doctor about some other kind of aerobic exercise plan. One final point, we'll see later in the seminar that social factors help significantly. So if you're going to walk, why not do it with a friend? People are almost as good as a dog. Just get out and walk, and your brain will be glad you did. Now, as you know, my wife is a professional dog trainer, so of course I had to get, dog walking worked into the seminar. But if dogs are not your thing, you're free to try other kinds of animals. Let's say alligators, or reindeer, or iguanas, or even turtles. The main thing is get some exercise. Let's focus in more detail now on Alzheimer's disease, or AD. Not only is AD the number one fear of many growing old, it also places significant burdens on society, on family, and on other people. Virtually every minute someone in the U.S. is diagnosed with AD. Millions of caregivers devote billions of hours of care, and the net result being billions of dollars in cost to the nation and inestimable cost to families. In fact, some families will go hungry in order to care for a loved one with AD. As devastating as AD is here in the U.S., a high-income country, the projected effects of AD are expected to be much worse in the low to middle-income countries around the world. Perhaps half of this increase is due to longer lifespans in the global population. In other words, improvements in the overall quality of life, which leads to longer lifespans. And that has the effect of more people being diagnosed with AD, since they're living longer than their parents or their grandparents. AD is a complex problem. Billions of dollars have been spent researching cures, but the only consistent finding is failure of advanced treatments. Most research paths are predicated on a single theory of disease source, and that theory is being seriously questioned these days. And that's a good thing. Science can advance when negative results cause a rethinking of a problem. But let's not let turmoil in the drug research obscure the most important known fact about the disease today. Up to 35% of your risk is modifiable. That means each of you can help lower your risk today. In fact, some recent studies from the UK show that material reduction in AD rates is possible. So take heart, there are things you can do to help, and let's explore them next. So where are we relative to AD in 2019? We'll look at 4 areas. First, current treatments and trials. Unfortunately, the news here is not as good as we would like. Second, studies with religious orders show that building cognitive reserves of brain power can really help lower the risk of AD. Third, detecting AD early in life. Research suggests that early detection is the best path to prevention and recovery. The better we can do this, the better we can apply new approaches with promise. And fourth, new approaches in the pipeline and what they can mean to the treatment of this disease for us and for our children and for our grandchildren. Unfortunately, by the time AD is diagnosed, it can almost be too late. Treatment options today are very limited once a fully confirmed diagnosis is rendered. The disease is likely present decades prior to diagnosis. At a typical age of diagnosis, the brain has changed dramatically. The thickness of neurons in the cortex have thinned considerably. The white matter of the brain, the connections of the various parts of the brain to one another, are atrophied. The brain has just overall shrunk. 2 changes in particular stand out. The first is amyloid plaques in the white matter of the brain. These are now understood to form an accumulation of a specific amino acid, alpha-beta 42. This amino acid is naturally produced in your brain, but in AD, alpha-beta 42 is not cleared sufficiently, and it builds up, leading to plaque. Inside of the neurons, there are tangles in the basic cellular machinery. These tangles interfere with normal neuron operation. The tangles are caused by the presence of a misfolded, naturally occurring protein called the tau protein. This misfolding seems to be caused either by the accumulation of alpha-beta 42 or by a cellular mechanism unknown today. And up until today, it was generally accepted in the view of researchers that the accumulation of alpha-beta 42 and tau were intimately related to the loss of cognitive function, and thus most drugs targeted the removal of amyloid proteins. But that assumption may just not be as valid as once thought. Here's a good example from 2016. A major newspaper touted an AD treatment, quote, within reach after a successful trial. Note that the drug switched off the production of amyloid plaques. A year later, a different kind of headline. The drug just did not work on patients at an earlier stage of the disease. And these headlines have continued into 2019. It seems that drugs which show early promise just do not show significant impact when tested in larger trials. So something's going on between testing drugs on a small sample of the population and then widening the study to larger pools of subjects. Part of the problem deals with evaluation of what impacts what. And for real insight into that aspect of research, we have to thank some nuns. A particularly difficult aspect of any scientific study of AD is the length of time over which the disease develops. It's decades. How does one get a control group to compare changes of lifestyle, etc.? Well, religious orders offer a fantastic opportunity in this regard. A group of nuns live a very similar lifestyle over many years, decades often. One group of nuns in particular, at Notre Dame, contributed greatly on our understanding of how to lower the risk of AD. And that is, building what is called cognitive reserve dramatically lowers your risk of AD. The world is a better place due to these nuns, not only because of their charity, but because of their contributions to science. The initial finding was that nuns who expressed in their daily journal a high density of ideas, in other words, they had a rich writing style, were significantly lower in risk for AD. The results caused a flurry of studies examining what other activities led to lower risk of AD. The results were fascinating. For example, bilinguals rarely get AD. Likewise, people who play musical instruments, or read a lot, or play novel games. It was noted that the earlier such reserves were generated, the better, but starting even, again, that phrase, later in life, had positive effects. The key finding coming out of AD research today is that we need to detect it as soon as possible. The sooner someone understands their risk, the sooner treatment and the sooner building even more cognitive reserve. And there's some very promising developments here. First, there are clear genetic markers for elevated risk of AD. The best example is a gene variant called APOE4. Inheritance of this gene variant is associated with significantly elevated risk of AD. Common genetic tests like 23andMe do test for this gene variant, and this testing can be done prior to conception and birth, well before any symptoms appear, and hopefully before any brain changes. Later in life, we can test for the presence of an imbalance of the critical amino acid alpha-beta-42 in cerebrospinal fluid. This is done by puncturing the spinal cord in the lower back and withdrawing some fluid. Several years ago, this was deemed a risky procedure. However, recent experience in Europe indicates that the procedure is low risk and can easily be tolerated. There's also early tests with the detection of substances in saliva that could obviate the need for CFS monitoring. Saliva monitoring would allow safe, frequent tests to detect any onset of the disease, which could dramatically improve detection and early treatment. Finally, tremendous progress has been made in developing compounds that pass the blood-brain barrier and highlight brains that are high risk of AD, but prior to symptoms being presented. All of these procedures mean that today it is possible to identify a person at risk of AD decades before the symptoms present. But the majority of procedures are still applied late in life and too close in time to the appearance of irreversible brain damage. The failure of research to produce any reasonably effective treatment of AD has led a significant segment of the research community to now question the underlying assumption that has guided drug development for the last several decades. This assumption is termed the amyloid hypothesis. In other words, the assumption that amyloid plaques in the brain of an AD patient causes the impairments of memory. Well, what if that weren't true? What would we do then? Research would go in a very different dimension. The working thought now is that AD reflects inflammation of the brain, and that the amyloid plaques are a defense mechanism against this inflammation. There's anecdotal evidence that supports this thought. People who take anti-inflammatory drugs to treat rheumatoid arthritis rarely get AD. So could this be a more fruitful avenue of drug research? If the source of AD is related to inflammation, then activating the brain's cleanup mechanism should be able to help. And new research from as recent as April of 2019 shows outstanding promise in animal models. In such studies, the entire genome of the animal is evaluated for targets that might affect the brain's ability to address inflammation. Of note, it seems that one gene in particular, CD22, was important in the cleanup of cellular debris which were related to inflammation byproducts. By restoring a natural balance in the animal's brain, not only was memory improved, it was actually restored in some cases. The workhorse of this action were cells called microglial cells. You're going to hear a lot more about these cells in the future. They seem to be key to the new hope in the treatment of AD. And if we're going to reevaluate AD, well, we should start at the beginning, the evolutionary beginning, and researchers have. The question now is, why has AD not been eliminated by natural selection, since AD has a genetic component and is clearly deleterious to a human survival? The working thought is that AD represents a new impact of our modern environment on our immune system as compared to that of our prehistoric ancestors. Those ancestors had constant low-level immune activation due to contact with soil, animals, and animal byproducts, for example, hair, feces, etc. Today, in our modern ecosystem, we have nowhere close to such levels of immune activation. This concept has been explored as the phenomenon of anti-fragile. Some biological systems need stress to develop normally. Bones need to be stressed to grow strong. Our immune system needs to be stressed to grow strong as well. Not too stressed, but perhaps stressed more like our ancestors, playing in the dirt, walking barefoot, being exposed to pollen in the air, etc. Such stressors make your microglial cells grow up to be strong and therefore useful in fighting inflammation and lowering your risk of AD. There is data that support this view, and it looks like a fascinating avenue of research in the near future. To close this section, I do want to make you aware of some new research that has great promise, but still faces some skeptical reception within the scientific community. The work is associated with Dr. Dale Bredesen and is supported by public medical research. By using a rigorous protocol of exercise, nutrition, and supplements, custom tailored to a specific individual, dramatic results have been obtained. The cost here can be significant. The process is complex. But there are now 100 testimonials and growing as to its effect. I would note that the approach is consistent with what the general scientific community is now saying. AD is a result of inflammation of the brain. If you have a loved one suffering from AD, then you should be aware of this approach. But caution is advised prior to full-scale commitment to any program and its cost. But let's end this section on a positive note. Each of you can lower your risk of AD with lifestyle changes. Modifiable factors account for 35% of the risk of AD. And I present a summary of the things that you can do today to reduce your risk. This summary was published by the leading journal of medical science, The Lancet. Look at all the actions you can take today, now, to lower your risk. There is no silver bullet. There is no pill. You need to exercise, walk that dog, talk with your neighbors, join a lifelong learning group, and eat right. You and your brain will be glad you did.
Time now for Homer to weigh in on the section's summary. And to put it bluntly, Homer is worried. Those of you who watch The Simpsons know that Homer's lifestyle is not exactly conducive to good nutrition, aerobic exercise, and building cognitive reserve. So Homer knows that he's at high risk for AD. But without rationalizing, Homer can truthfully state that there are positive developments that show great promise for all of us, even him. Each of us can do something as of today to help lower our risk, even Homer. We now turn our attention to some new horizons in brain research. The first area we cover is the horribly named default mode network of the brain. This brain network is shown in the solid yellow areas in the rotating brain structure on the slide. Note that this is a significant area of your brain, and it's very, very important. What does it do? Well, a picture is worth 1,000 words, as they say. Here is a fanciful depiction of the default mode network, or DMN for short, and what it does in a typical human brain. In essence, the DMN is the mind-wandering network. It's what your brain does when it doesn't have anything better to do. I think once you look at some of the thoughts in the diagram, you'll see some familiar stuff and realize that your brain does this quite a bit during the average day. Let's take a closer look. You measure the operation of the DMN in an MRI scanner as shown on the right. The subject goes into the scanner and has no assigned task. They just lay there thinking. When they do that, the DMN areas of your brain synchronize significantly. Now, much of that synchrony is probably thinking, when do I get out of here? But once you get used to the noise, subjects report that they fall into the thought patterns like this. In other words, their mind wanders, and the synchrony of the DMN reflect this. Suppose we now give you a task to do, as illustrated here. You're to report the animal in the picture, not the words. So on the second row, second picture, you would say chicken, not elephant. When you focus on that task, there is a marked reduction in the synchrony and activity of the DMN. Why a reduction? Well, you're not doing this. You're not daydreaming. This is a robust effect shown across many different kinds of tasks. It's really kind of obvious, right? You're focused on the task, not mentally wandering about your psyche. Thus, the deactivation of the DMN is helpful. It lets you focus on the task. Now, there's a strong effect of age on the DMN. It turns out the older you get, the less deactivation of task synchrony when focusing on an external task. So think about that. The older you get, the harder it is to focus on a task since your DMN does not, quote, get out of the way. And hence your mind wanders and you do less well on the task at hand. Here we have the blindingly obvious being confirmed by advanced brain research. I wonder how much that cost. Wouldn't it be great if we could positively affect this? In other words, to keep better control of our DMN and focus better on the task at hand. Well, it turns out there's a great way. It's called meditation. Believe it or not, the use of meditation has been extensively studied in rigorous brain research and found to be very positive in the maintenance of DMN. Meditation traditions varied over several methods, Theravada, Saja, etc., and the results not only showed better ability to focus on tasks, but also increased brain volume over the whole brain. So dude, this is not just new age mumbo jumbo. This stuff could really help your brain. But don't take my word for it. Here's an ABC TV newscaster with some personal views. Let's take a look.
There's no way a fidgety and skeptical news anchor would ever have started meditating were it not for the science. The science is really compelling. It shows that meditation can boost your immune system, lower your blood pressure, help you deal with problems ranging from irritable bowel syndrome to psoriasis. And the neuroscience is where it really gets sci-fi. There was a study out of Harvard that shows that short daily doses of meditation can literally grow the gray matter in key areas of your brain having to do with self-awareness and compassion, and shrink the gray matter in the area associated with stress. There was also a study out of Yale that looked at what's called the default mode network of the brain. It's a connected series of brain regions that are active during most of our waking hours when we're doing that thing that human beings do all the time, which is obsessing about ourselves, thinking about the past, thinking about the future, doing anything but being focused on what's happening right now. Meditators not only turn off the default mode network of their brain while they're meditating, but even when they're not meditating. In other words, meditators are setting a new default mode. And what's that default mode? They're focused on what's happening right now. In sports, this is called being in the zone. It's nothing mystical. It's not magical. You're not floating off into cosmic ooze. You are just being where you are. The cliche in self-help circles is being in the now. You can use that term if you want, but because it's accurate, it's slightly annoying, but it's accurate. It's more just being focused on what you're doing. And the benefits of that are enormous. And this is why you're seeing these unlikely meditators now, why you're seeing the U.S. Marines adopting it, the U.S. Army, corporate executives from the head of Ford to the founders of Twitter, athletes from Phil Jackson to many, many Olympians, scientists, doctors, lawyers, school children. There's this sort of elite subculture of high achievers who are adopting this because they know it can help you be more focused on what you're doing and it can stop you from being yanked around by the voice in your head. My powers of prognostication are not great. I bought a lot of stock in the company that made Palm Pilot back in 2000, and that didn't go so well for me. But having said that, I'm going to make a prediction. I think we're looking at meditation as the next big public health revolution. In the 1940s, if you told people that you went running, they would say, who's chasing you? Right now, if you tell people you meditate, and I have a lot of experience with telling people this, they're going to look at you like you're a little weird most of the time. That's going to change. Meditation is going to join the pantheon of no-brainers like exercise, brushing your teeth, and taking the meds that your doctor prescribes to you. These are all things that if you don't do, you feel guilty about. And that is where I think we're heading with meditation, because the science is so strongly suggestive that meditation can do really, really great things for your brain and for your body. The common assumption that we have, and it may be subconscious, is that our happiness really depends on external factors. How was our childhood? Have we won the lottery recently? Did we marry well? Did we marry at all? But in fact, meditation suggests that happiness is actually a skill, something you can train just the way you can train your body in the gym. It's a self-generated thing. And that's a really radical notion. It doesn't mean that external circumstances aren't going to impact your happiness. It doesn't mean you're not going to be subject to the vagaries of an impermanent entropic universe. It just means you are going to be able to navigate this with a little bit more ease.
The second new horizon we're going to talk about is less than a decade old. It deals with the bacteria in your gut, in other words, your intestines. As it turns out, there's strong correlations between what is in your gut and the quality of your life, especially as you age. In this section, we'll investigate if gut microbes can affect your brain, and if so, are the effects harmful, beneficial, or both? It's a fascinating story, and research in this area is highly active and interesting. Let's take a quick look at why this area of research is so active today, and the bottom line is numbers. You might think your brain has a lot of neurons at 84 billion. Well, there's lots more microbes in your body than cells in your brain, by a factor of 1,000 or more. That's a lot of microbes. And it turns out a lot of different microbes. For example, there are over 10,000 different species in your body. But the real number that's important is the 90% number at the top of the slide. That's the number of diseases of the body that can be linked, directly or indirectly, to microbes. Mind-blowing, is it not? Now, what's that got to do with your brain, aging, or dysfunction? Well, a lot. The community of bacteria in your gut, the microbiome, has been linked to a wide variety of health conditions, including autoimmune diseases, resistance to infection, many types of cancer, asthma, and cystic fibrosis. New research shows that this community changes with age. Most importantly, the microbiome becomes less diverse, and there's a decrease in good microbes, which seems to be associated with an increase in fragility. Such decreases in good microbes are often associated with obese subjects. These changes are globally associated with aging. But what about brain disease? Recent research has shown a clear link between your gut and your brain, and is bidirectional. What is in your brain affects your gut, but just as importantly, what is in your gut affects your brain. This pathway can be shown to affect anxiety, depression, pain experience, autism, and others. Recently, the motor defects of Parkinson's disease were transmitted to the brains of mice via bacteria loaded into the gut, most probably via the vagus nerve, as shown here on the slide. Other research has shown that Alzheimer's disease can begin in the gut, cause inflammation in the brain, and even transport amyloid substances from the gut into the brain. In essence, you are not only what you eat, but your brain is too. Gut microbes are also involved in the way your body responds to cancer. Emerging research shows that an individual's microbiome has significant effects on how various cancer treatments are tolerated and, more importantly, how they impact the reaction of tumors to advanced cancer drugs. Suffice it to say, there's a lot going on here. We only know a little, but the research community is working hard on understanding it, and it promises to be very impactful. This brings us to 4 very innovative forms of treatment. Not $1 million monoclonal antibodies or other esoteric kinds of high-tech stuff, but practical, low-cost treatments which are being tested now. First, we talked earlier about obese subjects having a bad balance of gut microbes, so caloric restriction is very helpful with such subjects, as long as the disease has not progressed too far. Second, I know I'm a broken record on physical exercise, so you get the dog walking advertisement here for physical activity, right? Third, we're in the very early days of transplantation of microbes from one human to another, but early results are very positive. And then fourth, there are probiotics. Let's talk about them in more detail. There are really 2 categories of food that have been shown to have positive effects on the aging of your brain overall and on neuronal degenerative diseases in specific. Prebiotics, shown on the left, often fruits and vegetables, and probiotics, shown on the right, often fermented foods. Probiotics are classes of food which contain live microorganisms and are linked to positive changes in the gut microbiome. Prebiotics are classes of food that, quote, feed probiotic microorganisms. While research has shown positive effects of probiotic consumption in elderly population, care needs to be taken so that one does not overdo it. Also, be careful on what you believe in terms of popular press and TV. There are wild claims out there. You do not need to overdose on expensive pills from the health store. You do need to do what your mother and father told you to do. Eat your vegetables, prebiotics. Don't be afraid to try new foods like yogurt, probiotics. Don't be a pig at the table. In other words, stay lean. Go outside and play. In other words, get some exercise. Who knew that our parents were so smart? So what does Homer have to say about this? Well, Homer is amazed that meditating for something other than beer can be good for you. But Homer and I encourage you to evaluate meditation. You might be glad you did. Then Homer engages in that kind of selective memory that he's famous for. Whoever told him to do those things? I'll bet his parents told him, just like our parents told us. Do those things. We might not have listened then, but it's not too late as we start to age. In this last section of the seminar, we'll cover 2 major items. First, what can be done to help your brain when your brain is injured? In particular, we'll look at stroke. Second, how can your brain help your body when your body is injured? In both areas, there's exciting developments in terms of progress. So let's take a look. Stroke is an event that harms an area of your brain. There's 2 types. By far the most common is termed ischemic stroke. It's a condition where something plugs a blood vessel in your brain and the affected neurons are deprived of blood flow. Brain neurons are notoriously hungry. They consume over 25% of your caloric intake each day. They quickly die if blood flow is cut off. The second type of stroke is when a vessel wall breaks at a point of weakness. This causes an interruption of blood flow as well as a swelling of the brain. This is a double whammy, since neurons are starved of blood and the brain overall gets increased pressure, since the skull cavity is fixed in volume. In the U.S., stroke is a prime cause of long-term disability, and it results in over $40 billion of annual economic cost. Stroke is a global problem, where lifestyle is the key contributing factor. Steps to lower risk are easily found on the internet, and most probably with an annual discussion with your doctor. Current treatments for stroke are not satisfactory on many levels. Since stroke involves the death of brain neurons, one hope was that stem cells or associated factors would be the magic bullet in treatment. As we see on the left, there's several sources of stem cells and their factors. But unfortunately, out of 1,000 substances tested over the last decade, only one is credited as a therapeutic treatment, and it must be administered within 4.5 hours of stroke onset, which is almost impossible to achieve. A second line of investigation was early intervention. Immediately following a stroke, get the patient up and moving. As it turns out, this has no therapeutic effect, as shown on the right, in terms of regaining the ability to walk. Note that over time, there is recovery of function, but it takes time, lots of it. 20, 30 days is often the case. So there's still lots of work to be done here in terms of developing an effective recovery treatment after stroke occurrence. But there's some very positive news on widening the critical window for initial stroke treatment, something called a thrombectomy. Recall that most often, stroke is caused by a clot of blood blocking a blood pathway in the brain. We see here, at the red arrow, the blockage of such an artery in the brain. Up until now, such a blockage had to be treated within 4.5 hours of initial occurrence, usually an impossibly short window of time. But new technology from several medical companies offer excellent techniques for removing a clot. The video shows a catheter inserted into the blood vessel, piercing the clot, and then stopping blood flow temporarily in order to remove the clot completely from the blood vessel. After such a procedure, the vessel allows blood to freely flow again, as shown here. The red arrow still denotes the previous location of the clot. This is marvelous. You still do not want to get a stroke, but the treatment window now has been widened significantly. Field research is now showing an expansion of stroke treatment window to approximately 24 hours. The numbers on this slide are from Great Britain, but they're representative of many countries. By removing the clot within 6 to 24 hours, about half of all patients recovered functional independence as measured 3 months after stroke occurrence. Prior to the use of thrombectomies, 90% of the patients either died or were permanently disabled. While more work remains to be done, this is very good progress. Of the new technology we talk about next, many originated in a set of experiments done in 2008 in the laboratory of Dr. Andrew Schwartz at the University of Pittsburgh. This research was the first to show a monkey's brain directly controlling a robotic hand at a fine level of detail. The monkey is only connected to the robotic arm via a set of electrodes in his brain. A computer reads the signal and then causes the arm to move. The monkey attempts to do a series of tasks and then is rewarded with juice. In early videos, the monkey resembled Yoda raising the starship in the Star Wars movie, so the name Jedi monkey was coined and stuck. The monkey and the video is famous in the research community, and now with you too. From the vantage point of 2018, the experiments of 2008 seem quaint, kind of like your first mobile phone. The old stuff was big, slow, and expensive. The Jedi monkey showed what could be done. The task at hand next was to make it small, cheap, and vastly more functional, just like the phone in your pocket today. Brain electrodes are now made in the range that are tiny. They have embedded material to sharpen the resolution of detected brain activity. But the real breakthrough has been in hand and arm technology. Today, there are robotic hands that have the full 30 degrees of freedom of the hand on your body. Such robotic hands are revolutionary in terms of capability, but they still need to be controlled by our brain and software in a computer. That's where the current challenge is located, and that's the current focus of research. There's also follow-on research by different technology labs which focus on improving the technology so that surgery is not required to implant electrodes. This would eliminate a major item of cost and risk. A sample headset is shown on the left, and a sample use is shown on the right, control of a wheelchair. The wheelchair would be completely controlled by thought and would be used by people who have lost the use of their limbs. A different kind of research is enabled by the Jedi monkey deals with a device called an exoskeleton. This device can be used by people with lumbar or thoracic spine lesions, people who still have use of their arms but not their legs. Fantastic progress is being made here on a Jedi timeline. One outstanding use is to allow people with lumbar spine injuries, people who would normally be confined to a wheelchair, to walk again independently. This is a major improvement in their quality of life and a technology that is rapidly improving in the market. Helping people to walk again is a major advance in science. Yes, the state-of-the-art device is a bit clunky, but it is a miracle to those who are bound in a wheelchair. But Jedi technology is always improving. Technology typically miniaturizes, and this clunky device on the right is now this. It is a flexible strip of high-tech plastic called E-Dura that can deliver electrical stimulation to a set of nerves. It can also deliver chemicals. Let's see it in action with a rat who has sustained spinal cord damage similar to the person shown in the slide on the right. It will be obvious that a researcher is narrating, and unfortunately no closed caption is available.
The E-Dura was implanted over lumbar segments of adult rats. They received a severe contusion that spared less than 10% of spinal tissues. Rats were maintained bipedally in a robotic bodyweight support system over a moving treadmill belt. Without any stimulation, the rats were completely paralyzed. A serotonergic replacement therapy delivered through the chemotrode did not promote movement. When adding unilateral electrical stimulation, rats instantly regained movements on the stimulated side. Concurrent chemical and bilateral electrical stimulation promoted weight-bearing locomotion of both legs. The electrochemical neuroprosthesis restored continuous, coordinated locomotion in the paralyzed rats.
Development of this technology is targeted at implantation of such a small device into the spinal cord of accident victims. Yes, it's early days, but progress has been rapid to date. The person who receives such a device would not need an exoskeleton, but would be able to walk unassisted and free. Wouldn't that be amazing? In 2018, this technology has now moved from mice to non-human primates, an essential step if this kind of technology is to be used in humans. Of particular note here is that brain signals are sent wirelessly from a brain implant to an implanted pulse generator in the monkey's hindquarters. This is a much safer technique in terms of protection from infection and for long-term use. The area is moving rapidly and in a very positive example. Now let's look at two examples of the state-of-the-art in humans. The first represents outstanding lab work on restoring the use of hands to those who have suffered a debilitating injury of the spinal cord. Independent living is always the standard goal of such people, and this technology is moving in a direction that will support that goal, thanks to the work of brilliant research scientists and dedicated patients.
I had just finished my freshman year of college. I was out in the ocean and I dove out and into a wave, something that I'd done many times before. I dove into a sandbar that I'd drifted in, which fractured my spine and damaged my spinal cord, and that left me as a C5 quadriplegic. I kept asking the doctors, what can I look forward to in the future? One of my doctors said, hey, we want to try this muscle stimulation device. It really sounds like it's something out of a science fiction novel, reconnecting my mind to my body.
My name is Gaurav Sharma. I'm the lead investigator on the NeuroLife program at Battelle. So NeuroLife is an electronic neural bypass technology that can link the brain directly to the limb it controls. We are developing this technology for people with paralysis due to spinal cord injury so that they can regain control of their own hand. Ian Burkhardt is our first patient in this study.
Independence is my #1 goal. And regaining any use of my hands will really improve my independence. So it was something I was all for. You good? Yeah.
So this technology has three main components. The first component is a tiny chip that is surgically implanted in Ian's brain and that records Ian's brain activity as he's thinking about moving his hand.
You want a little more slack? No, that's fine. It's good? Okay, cool. Yeah.
The second component is a computer algorithm that decodes Ian's brain activity and interprets the movement that he's thinking about. And the last component is a wearable sleeve, which has up to 160 electrodes, which activates the individual muscles to evoke the attempted movement.
You said hand open first? Hand open first, yeah. When I first started with the study, just trying to open and close my hand was extremely challenging. I never had to think about moving my hand. It was just something that naturally happened. So it was something that took a lot of mental strength. Okay, you ready? Yeah. But today, with practice, I'm able to pick up an object and manipulate that around in space. I'm able to move individual fingers. I can do some complex grasps. You're looking good today. Yeah. You know, we've done everything from picking up a bottle and pouring it to playing Guitar Hero. Just being able to control more of your body that I thought I had lost forever is something that's really exciting and really promising.
Going to be a while before a system like NeuroLife restores anything like full functionality. But it's a first step towards a future where a broken connection between mind and body doesn't have to be permanent.
The goal of this project is someone can actually take it home with them and use it for their activities of daily living. We are working very hard on the hardware side to make it portable and wearable so that Ian can in the morning wake up, put the sleeve on, and he should be good to go.
If I can help move science so that in the future someone with an injury like mine, they'll be back going on with their lives in a short time, that's something that, you know, I'll work as hard as I can for.
The apparatus we just saw is only suitable for laboratory work. It requires a brain implant via surgery and still to be fine-tuned in the lab. There's other research that has progressed to the point where the prosthetic device is ready for home use. The cost is still way too high, but think about the cost of the first real computer. The point here is to see, can the device take the rigors of being used by someone in, quote, real life for up to a year? Let's see the start of an experiment that promises to be fascinating.
This is Johnny Methane. He used to deliver bread. Now, he's about to become a cyborg.
Now here's where I'll need help.
Johnny lost his arm in 2005 to cancer. Today, he's becoming the first person to live with an advanced, mind-controlled, robotic arm.
I want to get my life back as it was before I lost my arm, or as close to as I can get.
He's a little excited.
Santa said Johnny was going to get something special this year for Christmas. Put on some pounds, huh? Yeah. Yes. Come on in.
For the last 4 years, Johnny and a few dozen other men and women have been testing versions of the MPL at the Johns Hopkins Applied Physics Lab in Maryland. But today is different. Researchers are delivering the arm to him to keep for a year and do pretty much whatever he wants with it. It's part of a 10-year-long research project funded by the U.S. Defense Department to create a prosthetic that could replace the human hand and arm.
This is the first time the MPL is being left with someone for actual out of the lab use. So after 3 days, we get out of Dodge and let Johnny use it the way he wants to use it.
I am going out of my head. Yes.
He's the kind of pioneer of this take-home, which is the essential next step, kind of getting approval, getting it out to be a functional device.
The MPL has 26 joints. 17 of them can be moved independent of each other. And over the years, Johnny has gotten really good at using it. Watch this. And remember, he's doing this just by thinking. Johnny's moving each finger individually in order. This is something that no one else can do.
Ta-da!
In the next year, he's going to be pushing the arm to its limits, and he'll be checking in with the team at Johns Hopkins with reports. They're going to use the data that he collects to make improvements to the arm and also document what it can do that other prosthetics can't. And Johnny has big plans, too.
Before the year's up, I plan on playing the piano. Never played a piano in my life. It might be one song, but I'm going to play a piano.
Gotta have it.
Gotta have it, they say.
Hey everyone, we're going to be following Johnny for the next year as he lives with his new arm, and we'll be uploading videos as he progresses with it, so stay tuned.
After that, Homer is uncharacteristically speechless. Basically, Homer thinks this is awesome. I hope you're as thrilled about this program as I am. Over the next decade, amazing progress will be made. These advancements will not only bring hope to our generation, but also many miracles to our grandchildren. This concludes the seminar series. I hope you've enjoyed it as much as I've enjoyed making it. While your brain still holds most of its secrets, there's an emerging story of its operation that can help us prevent decline, repair trauma, and recover function. The story is replete with dedicated scientists and brave patients who are pushing the bounds of knowledge for the sake of their fellow humans. I thought it might be beneficial to give you my 3 thoughts to take away. The top 3 ideas which distill the essence of this seminar. I call them the 3 C's. The first is to conserve your brain. Your brain is a marvel of the universe, so take care of it. Do what your mother and your father told you to do. Sit up straight, eat your vegetables, and walk the dog, or your cat, or your pet iguana, or whatever. Do it with a friend if possible. The social stimulation, the aerobic exercise will do you and your brain good. The second is to celebrate the progress in the understanding of an organ that's more complex than the galaxies above our head. Celebrate the progress that we've seen in relieving human suffering via neurotherapeutics. If you can, take a neuropsychologist out for lunch or a drink someday. And then finally, consider the fact that your brain and all other brains on this planet have unconscious systems that encode evolutionary skills essential for our emergence as a species. Perhaps are unhealthy or unhelpful in today's society, but use your advanced brain systems to deliberate and construct actions that can moderate them as appropriate in today's society. The audition of a player for a symphony is a good example. To conclude, I have a short film of credits to thank people who were so helpful in the construction of this seminar and a few pictures of Austin, Texas, my home. This is Steve Saltwick.
Feel like cutting the rug rosin up the bow and let the good times roll. Well, all I wanna do is play, and if you ask me why, I'll say, why, I'm a Texas fiddle man. Fiddle. Well, that old lone star is shining down on me tonight. I feel like I'm making love and staying up all night. Lord, I was born with a fiddle in my hand. Well, I'm a Texas fiddle man. A Texas fiddle man. Rosin up the bow and let the good times roll. Well, all I wanna do is play, and if you ask me why, I'll say, why, I'm a Texas fiddle man. And if you're gonna play the fiddle, you gotta have a Texan in the band.